The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS, welcome to today's webinar on test estimation. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. I'm the author of a bunch of books on software testing, including the bestseller, Managing the Testing Process. Attendance at today's webinar earns PMI PDUs. A big thank you to Vicki Sasser for reviewing the materials for PDU status and for making valuable suggestions. PDUs are available for live webinar attendance only. Before we start the presentation, a couple housekeeping notes. Feel free to submit your questions at any time, but please note that I only answer them at the end. There is no need to ask for presentation copies. The presentation is on the web. Go to rbcs-us.com, go to the Resources tab in the upper middle of the page, and from there navigate to the basic library and you will find the slides there. By attending this webinar, you have automatically been registered for the free e-learning drawing. Check your email over the next couple days and watch that spam filter. Finally, you will notice that my voice sounds kind of odd. That's because I have a head cold. I will be periodically muting myself to avoid sneezing and coughing into your ears. We'll do the best I can to avoid doing that. As far as the scratchiness of my voice, I'm afraid that I cannot fix. I will periodically be treating it with iced coffee and water and so forth, but I'm afraid it's not going to be a whole lot of fun to listen to. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS, we're a not just for profit company. So, what are we trying to do here with test estimation? Well, we're trying to figure out things like how many testers do we need, how many tests do we need, how many bugs will we find, how long will testing take. These are things that we want to get answers to. Now, what is a good estimate? I mean, anybody can, you can estimate. Anybody can make up numbers. I can make up numbers to, go with each one of those questions I just asked. But is that a good estimate? I think we all have a sort of a sense that is not, if the numbers are purely made up, but okay, what does actually constitute a good estimate? Well, here's what I would say. A good estimate is one that accurately predicts the future. So we say, it's going to take this many testers to get through the testing, then that's how many we needed. If we say it's going to take this many tests, that's how many we needed. The prediction comes true within some, degree of accuracy. Obviously, if you predict somewhere in the order of 10,000 tests and you end up having to create and execute 9,500 tests, that's probably pretty good accuracy. That's probably good enough. Plus minus 5% for an estimate is pretty good. So that's what I'm talking about, accuracy. And it also should be useful as a guide in the sense that it lays out a path for us that we can follow. Whether this guide be, in the form of burn down charts, work breakdown structures, whatever it is that we're using, the estimation process should be one that allows us as the project proceeds to know, are we on track? And if we're not on track, what would be some smart things to do from a course correction point of view? Now, you also want an estimate to be realistic. So it shouldn't be missing any tasks that have to be carried out. We're talking here specifically about testing tasks, but of course this applies to any kind of tasks, including development tasks. Any tasks that need to be carried out should be included. Also, risks. Now here I'm talking about project risks. risks that could affect our ability to carry out the tasks and the project as planned. We need to understand what those risks are and manage those appropriately, put appropriate mitigation and contingency steps in place. And the estimate needs to be actionable to be good. By actionable, I mean that we know who's going to do the work. There's assignment of people. There are resources. There are dependencies. We know what those dependencies are, and we're planning to deal with those dependencies. So it's not like we're going to get to a situation where it's time to run some task and we go, oh no, we can't do that. Now, there are basically three parts to the estimation process. One is asking experts and owners. Ask the people who are actually going to do the work. Ask people who have done the work before. This is the most common, and goes by various names, which we'll see and talk about. Now, another approach which should be included in your estimation process is the use of metrics and industry averages. Ideally, historical metrics from similar past projects that you've been involved with. Failing that, then at least looking at industry averages and saying, does what we're proposing make sense? And then finally, there's a negotiation piece. It is often the case that, as the old saying goes, people's eyes are bigger than their stomach. They serve themselves more than they can eat. The Mythical Man Month book by Fred Brooks certainly didn't create the phrase, but aptly used the phrase of trying to put 10 pounds in a 20-pound bucket, or 20 pounds in a 10-pound bucket. Sorry. And that kind of thing goes on all the time in software engineering, especially, including other fields, but software engineering particularly. You have to think about the negotiation of getting to something that we can all agree on as part of this estimation process. And in fact, I want to start with that because that's probably one of the most neglected parts, but it's the part that is when it's neglected and when it's not managed carefully is going to lead to the downfall of any estimate, no matter how technically proficient you are from a project management point of view at creating estimates. If you can't handle the negotiation part properly, then you are not going to achieve a good estimate. Now, focusing on testing in particular, we're talking about this negotiation piece. It's important to understand that disagreements can easily arise out of mismatched expectations. It can be as much about a mismatch of expectations as about facts. Because if you're not on the same sort of set of expectations to start with, you're probably looking at a different set of facts. So of course you're not going to be reaching an agreement. So let's talk about what different expectations we could have that would be workable in reaching an agreement about test estimate, and what expectation would be toxic. There's another nose blow there. Okay, so the first three expectations on the list here are expectations that, if they're mutually held by all of the managers and stakeholders involved in discussing the test estimate, will allow us to come up with an estimate that is a good estimate. And the last one is one that creates an impossible scenario. So the first one is that you're going to cover the test basis completely. Now, when I say test basis here, I'm referring to those things that your tests are based on, which would include the requirements, would not ideally would not just be the requirements. If you find that statement a little bit mystifying and you're like, what else could I possibly be basing tests on besides the requirements, I would refer you to the recorded webinar that I did on dimensions of test coverage. I think it was like a year or two ago. It's posted out on the digital library on the RBCS website. In that webinar, I talk about all the things that could conceivably be part of your test basis. Now, obviously, you have to have agreement on what the test basis is in order to be agreed on what it would mean to cover the test basis completely. So I'm assuming here that we have an agreement set from as a starting point about what the test basis is. First assumption there is that you're going to test everything completely. And again, I'm assuming that you have some way of having a discussion with people about what completely means. But that's their expectation, is you're going to test everything that's on that test basis set of documents and inputs and so forth. And it's going to cost what it costs. It's going to take whatever amount of time it takes. Some of you might be listening to this and be thinking, yeah, that's a nice life. That's some fantasy land that Rex is living in there. But there are actually organizations where this is the expectation. If you are, for example, in an FDA-regulated environment, FDA stands for Food and Drug Administration for those of you outside the United States. The FDA has regulations that apply to medical devices and medical software, and you have to satisfy those regulations. Those regulations are pretty strict in terms of coverage of your test basis. You don't satisfy those, and an auditor audits you before you try to release your device, you're not releasing it. You fail, boom, done, game over, thanks for playing. So, test managers in those scenarios have one argument taken off the table completely, because that first expectation is the one that's going to prevail. Suppose that you're not in a regulated environment and there are some constraints. One expectation that I have seen is that you're to do as much testing as you possibly can within the schedule constraints. Now, within those schedule constraints, cost is not an issue. Now, of course, ultimately cost is an issue, but there's only so much money you can spend in a finite period of time. But you're not going to be cost constrained, you're going to be schedule constrained. If any of you have been around as long, or close to as long as I have, I was around way before the Y2K stuff, but I was around for the Y2K stuff in the software industry, been in the software industry since 1983. For those of you who were working on software projects in the late 90s that involved Y2K conversion, you might be familiar with this particular expectation, which is, we're going to throw a lot of money at making sure that our IT systems don't go to hell in a handbasket when the clock strikes midnight. But the clock's going to strike midnight when it does. The project's going to be over when the project's over. So that's something that happens on conversion projects sometimes, is spend as much as we can to get as close as we can to complete, but understand that we are constrained. Now, the more typical reasonable expectation is the third one on this list, which is you're going to do as much testing as you can within schedule and cost constraints. So there's some limit on how long the project can go, and there's some limit on how much it can cost. That's probably the more typical one. If you are working in an Agile team, for example, the assumption is that the sprint or iteration, whatever it's called in your implementation of Agile, is going to end when it's going to end. And since you are probably constrained in terms of the number of people you have and the resources that you have on any given sprint, then you're cost constrained too. So it's basically, do as much testing as you can within that set of constraints. And all of these are perfectly workable, these three, as long as we agree. It's the fourth one that's going to get you in trouble, which is where people assume that they can constrain schedule, constrain budget, constrain the features. In other words, that this, we're going to release this set of features on this date. This is how many people and how much money we're going to have available. And by the way, it has to have perfect quality. You have to have found every single bug. And this is what I call breaking the iron triangle assumption. So the iron box and triangle here, if you think about this process, so getting the pointer up here, the spotlight up. A lot of times, you know, the first thing that we're going to do is define a set of features. Now in Agile, this is, of course, it's the other way around. The schedule is actually what comes first. You know, we predetermined the number of iterations that we're going to have, and then we select the features that we think will fit within that that set of iteration, or that iteration, excuse me. You know, iteration by iteration. But either way, you get the point that the features and the schedule will be defined either one first, then the other, depending on whether we're Agile or Waterfall. And then we're able to say, okay, well, you know, are there cost implications? Do we need new resources? Bringing in outside people, perhaps, outside tools. So now we're making a decision about cost. Notice that what's happening here is you can think of the features as defining the box, and then we draw a line for the schedule, and we draw a line connected to the schedule for the cost. And basically, any given software process that exists at any given point in time will have a certain quality capability. Okay? It's going to have a characteristic quality capability. Now, that will vary to some extent. You will see variability in the process. The less mature the process is, the more variability you will get. But it's going to have a characteristic quality capability. So if you just say, you know, we are going to constrain features, constrain schedule, constrain cost, you have constrained quality. You can accept that or not. A mature way of thinking about it is to accept that that's a constraint. And if that level of quality is not acceptable, then you would iterate. In Agile, you would say, well, if we don't have time to test all of these user stories in this period of time, which of them will we remove, right? In a waterfall, you might say, well, you know, we can either de-scope or we can extend the testing schedule. But something has to give there. And any attempt to just say, we're going to predefine features, schedule, and cost, and oh, by the way, you can't release any defects to the customers. You know, this is management by exhortation. This is one of Deming's hobgoblins. If you've read Deming, W.E. Deming, if you haven't read Deming and you're in the testing business, then go read Deming. You know, you should be familiar with his concepts about quality, because they're important, just as say Duran is. But yeah, management by exhortation, management by fear, by pressure. Sometimes this is referred to as Theory X management, which says that the only way to get the maximum output out of your workers is just to press the hell out of them and you know, subject them to ridiculous expectations in the hope that in their desperate attempt to achieve the impossible, they'll achieve the unlikely. It's based on the assumption that people are fundamentally lazy and don't care, which thankfully has not been my experience. If you're working in an organization where people are lazy and don't care, which, you know, I think of all the projects that I've been on, I can only think of one where I would have actually characterized a majority of the team that way in my 30 plus years in this business. If you're working on a team like that, what you need to do is find someplace else to work because the thing is that no amount of Theory X management will ever get that team to succeed. So what you want to be working with is a form of what's called Theory Y management, which if you've read, say, Tom DeMarco and Tim Lister's books like Peopleware and so forth, that's pretty reflective of Theory Y management. Tom Peters, the guy who wrote In Search of Excellence, is another guy who talks a lot about Theory Y management. Theory Y management basically says people are motivated and they want to accomplish good things. They need managers to give them the resources and clear obstacles from their way. Okay, so that's a lot about the human elements of this, and you might be thinking, maybe that's too much about the human element, but in my years of working as a consultant and as a test manager and so forth, I've come to conclude that the human element is quite important in this grand scheme of things. Okay, so now let's talk about the technical side of it for the rest of this discussion. By the way, I had a report of poor audio quality, but it was only from one person. I'm assuming that person's just having a connection issue, but if a lot of you are having issues with audio quality, do let me know, and we'll escalate that up to our friends at Citrix, our good friends who always love to hear from us when we complain about the problems that we have. They're going to have a hard time topping the one that happened last month, where a bunch of you were unable to get even logged into the session. Okay, so let's talk about the technical elements of this. So if we're talking about a traditional life cycle, a sequential or V model life cycle, then usually what you're going to do for your estimation is some form of a work breakdown structure. Now, a work breakdown structure is a hierarchical decomposition of a project, any project, into its major stages, and from there into activities, and then ultimately down to discrete tasks. So you could go various ways about doing this decomposition. I've used these 5 stages shown here on a lot of schedules. But you can also use, say, the fundamental test process as a way of doing that, if you're familiar with the ISTQB fundamental test process. I think, the important thing is that you start with a structure that is going to make sure that you don't leave anything out. As long as it works for you and not missing any tasks, then that's fine. Now, when you break down to the tasks, one of the things you want to do is follow project management best practices, which would include things like getting tasks down to the 1 to 2 day, maybe 3 days duration, and having a single person assigned to the task. There's a single owner, so you don't have accountability issues. Having the task produce a deliverable is also a good practice. Not all tasks will, but it's, ideally there would be a deliverable that can be reviewed so that we can say, yes, that task was indeed done. Now, again, a key thing here too is, not to forget anything. So, part of this is the framework that you use. Another part is what I refer to as thinking forward and thinking backward. So thinking forward and thinking backward is not the same as thinking forward and backward thinking. Encouraging backward thinking, but thinking forward is you're sitting there, you're creating your estimate, and you're going, okay, I've worked on test projects before, so typically this happens, and then this happens, and then this happens, and then this happens. And so you're able to kind of go through in your mind, just replay the movie basically of, well, what are the kinds of things that have happened on previous projects. Obviously, the first time you create a test estimate, this is not going to be very easy to do because you're speculating, but hopefully you've got someone available who can help you with that. Of course, if you're creating a test estimate, it's at least not going to be the first time you worked on a test project, so hopefully you can remember the kinds of things that have gone on past projects. But after a while, and the more you do it, the more experience you have, and the more you're able to go, oh yeah, I'm going to add this, and then we do this, and then we do this. Now, the thinking backward. What is the thinking backward? What I'm suggesting here is that if you are doing risk-based testing, which I would encourage you to do, at this point in time, whether you're doing a traditional life cycle or an agile life cycle, you should have gone through a risk analysis. So based on that risk analysis, you should have a pretty good idea of what you're going to test and how much. You should be able to think through, all right, during test execution, what are the things that I'm going to need to be able to test? What are the test suites that I'm going to do? This and this and this. You should be able to say, okay, I'm a functional test suite, performance, error handling, reliability, usability, localization, whatever it is that you came up with. So you know what those test suites are, and then you know how much risk was associated with those areas. So you should be able to say, yeah, I think this is like this many days, and this is this many days. And of course, we're going to come back to this in a bit, because this is you're probably having a whole lot of thoughts pop up in your head, like, well, how many days it takes to execute those tests depends on how many bugs I find, right? Yeah, we'll come back to that, but at least you can say to define or to run the test once would take this long, right? So you got that idea, and then you go, all right, now what would I need to develop to run these tests? You have to create the tests. You might have to create data. How about environments? Do you need to set up an environment, if you're doing performance testing? Staffing. Maybe you don't have anybody qualified to do a particular kind of test, so you're going to bring in a contractor or consultant to do that. You might even have to write a whole separate plan, like a performance test plan. So that's what I'm talking about, thinking backward. You're basically looking at what your risk analysis tells you need to test, and you're thinking through all of the things that you would need to do in order to get to the point where you could run those tests. Now, in Agile, what's going to happen is a little different, because you're going to have an overall test strategy that's been defined, and this should be in place at the point of release planning. Now, you're not going to know during the release planning exactly where every user story is going to go, and they won't have exact sizing and so forth. So it's during the iteration planning at the beginning of each sprint or iteration where you're going to estimate your features or user stories. A lot of times you'll be using a technique referred to as planning poker, or it might not be referred to as planning poker, but it is something like it. If you're not familiar with that, I'm going to describe it in just a minute. So we're going to come up with the number of story points, which is just basically a measure of effort associated with creating and testing that user story. And when you're assigning the test effort to the user story, you should be thinking about the risk level. Now, you want to make sure that you have good team involvement, and planning poker is supposed to be a team effort. Now, in the case of creating a work breakdown structure, a lot of times the way that will happen is that you'll create the work breakdown structure first, and then you'll go and have a team estimation session, say with your test team. So it's still a collaborative effort. You want to make sure that you do have that collaboration regardless of the life cycle, again, so that you don't miss anything and so that you don't underestimate things. Now, in Agile, it is important that we do the estimation properly, including the test estimation, because otherwise what's going to happen, because we are time bound, is you're going to get to the end of a sprint or iteration, and the testing's not going to be done, at least not done to the point that it really should be. And so a user story might be claimed as complete, and it's released, and we go, oh, look, our velocity is this, 30 story points per iteration or what have you. Well, okay, but you didn't actually finish all the testing. So when those under-tested user stories get out there and people start actually using them, they find bugs in them, right? So your velocity isn't actually meaningful because you weren't really done. And I've seen this happen in organizations that are following Agile. Is not unusual that the testing just basically gets curtailed at the end of the last day of the iteration. Declare victory and go home, as the saying goes. Which then, it's like, wow, what a surprise. The user stories that we were testing at the end of the iteration are always the ones that people have the most trouble with after we release them. Okay, so the planning poker. Agile has a lot of instances of what would be referred to in biblical terms as old wine and new skins. Basically rebranding of existing best practices under new names. If you're a cynical old guy like me, you say that people do that because you can make more money by rebranding something under your own brand name and making it sound like you made it up, rather than just saying, here's a best practice that's been proven for 60 or 70 years that I like to use, So again, being that cynical, I'm so cynical that I cut myself off from that. So I don't like rebrand things under my own name, and so maybe I'm missing a boat. But planning poker is just a new name for a technique that's been around since World War II called Delphic Oracle technique. And what you do in the Delphic Oracle technique or in planning poker is that you ask people, it's a group estimation effort. You ask people to estimate how long something is going to take, but they don't reveal their estimate to everybody when they come up with it. They write it down or pick a card or what have you. There's a number of ways of doing this, but you basically come up with your estimate on your own, and then you have a reveal where everybody reveals their estimate to everybody else, and then the high and the low estimators are supposed to explain their reasoning. Now, you might say, what exactly is that whole hide the number and then reveal it all at once thing about? Well, that's to avoid a problem called anchoring. Anchoring is where in a conversation, people tend to react to the last thing that was said, or in this case, the first thing that was said. So if people blurt out their numbers, like we're sitting in an estimation session and we're looking at developing some little script that's going to allow us to automatically test an API. And I, as a test manager, ask, how long is that going to take? And somebody says, I can do that in 2 days. Boom. Now everybody is anchored to that 2 days. Everybody's reacting to that. Now there are situations where you absolutely want to take advantage of anchoring, right? If you're in an auction, I mean, the whole reason that an auction is going to work is because of anchoring and people, reacting to each other's bids. But that's not what we're trying to do here. We're trying to come up with a truthful figure for how long it's going to take. So what you do is you allow everybody to come up with their number by themselves, and then we react to each other's numbers all by themselves. On each one in consideration, basically. If you're in the United States and you're watching the exceptionally dispiriting coverage of our upcoming presidential election, you will be quite familiar with the concept of anchoring and how it works, and how it can be detrimental to a fact-focused debate about any given topic. Now, there needs to be a limit on the discussion here. So usually what you have is the rule of repeat at most twice. So what I do is I have the high and the low estimator explain their numbers, and then we re-estimate. Again, same process as before, without revealing it until everybody's ready to reveal their estimates. And then, again, if we don't have agreement, try it one more time. But it's basically, three's a charm one way or the other. Classic Delphic Oracle would say that you use the average if you don't get agreement on that third try. Other people would say that you should use a mode or median value. You know, I think that's there are a number of ways of splitting the difference there. Usually what I see in this kind of sessions is that it just kind of gets worked out, it gets negotiated out. Point technique. This is not something I would expect to see used in an agile environment, just because it's kind of a heavyweight technique to use when you're talking about a small team that's trying to figure out what they're going to do in the next 2 to 4 weeks. But in the 3-point technique, basically what you're going to do is, instead of having a single estimate for each task, you have 3 estimates. That's hence 3-point. Best case, worst case, and expected case. And then the expected case is what's actually used for the estimate. But what you do is you run the estimate, you work breakdown structure, you put the best case and the worst case numbers in, and you look at how big the variance is in terms of the end date and the effort. And the bigger that variance is, the less precise, less accurate your estimate is. Now, there's a concept called the cone of uncertainty that I don't really have time to get into here in this discussion, but you can do a Google search on that. It's something that Steve McConnell has written about. And basically, the 3-point technique can be good at figuring out where exactly you are in the cone of uncertainty. So, you know, if you're doing a longer project following a sequential lifecycle model, or one of the traditional iterative models like rapid application development, then you might use a 3-point technique, or the combined Delphic, Oracle, and 3-point technique, which is called the wideband. Okay, so that's basically about extracting the individual wisdom from people, and it's important. Now, another thing that you need to do when you're doing an estimate, and this is true on any project, agile or sequential, is figure out what your dependencies are. Now, basically, the way you're going to do this is you're going to go through and look at the tasks that you've identified, whether for this iteration or for the entire project, and figure out which tasks have no predecessors. And then you identify out of the remaining tasks which ones are dependent only on previously identified tasks, and you capture that dependency, and you iterate that second step until you have captured the dependencies of all of the tasks. Now, if you're using something like an Agile, if you're on an Agile project and you're using like an Agile board, task board, you should be able to just kind of do this by inspection, by looking at the tasks, or if you're using a tool like Microsoft Project or Jira, and you're dealing with a small set of tasks, you can probably do this in an eyeball kind of way. On medium to large projects, it's better to use either sticky notes or index cards with tape, and a whiteboard or a wall that you can write on and paste stuff up on. I've seen this done in cases where you have like butcher paper hung up on walls, and that's used to kind of lay out a timeline and the dependencies between the tasks, and then ultimately that all gets captured into the project management tool. You need to understand the dependencies. Now, theoretically in Agile projects, you're supposed to select user stories that are independent, and that's fine. There might not be dependencies between the user stories, but there certainly can be dependencies like, I can't run a test for this user story until I have this particular piece of hardware set up, because this piece of hardware is necessary to run this test. So just keep that in mind. People will sometimes say, well, there aren't any dependencies in Agile because all the user stories are supposed to be independent. Well, that doesn't mean that the tasks that have to be carried out to accomplish the user story, to implement the user story, are going to be independent. Now, here's something that should be less of an issue on an Agile project, but can be a fairly significant one on a sequential project, is critical path. So once you get if you're doing a sequential project, once you get all your tasks into your project management tool with the dependencies, you want to look at your critical path or critical paths. And a critical path is any sequence of dependent tasks where any delay of any task along that sequence would end up pushing out the project end date, because you can trace backward from what it means for the project to be done through a path of dependencies along that chain, right? And hence the critical path. You can also have near critical paths where 1 or 2 day slip might not hurt, but a week is going to create a problem. So, you want to look for things like, phase gates, phase entry and exit criteria, issues associated with how the tests are broken down into groups, like sometimes people call test passes, a collection of tests that are going to be run against a given set of releases, and how many releases are you going to get, how many test cycles are you going to get. Think about external dependencies. As a test person, you are pretty much downstream from everybody else and everything else on the project. So you have to think about how something upstream could go wrong and affect you. Now, again, this is likely to be a bigger issue on a large sequential project than it would be on a smaller project where you got a team of 7 or 8 people following an Agile lifecycle. You're less likely to get caught up in this. But if you're dealing with big, complex projects, following a traditional iterative life cycle or sequential life cycle, then critical path issues can be a way that things get delayed. You also want to make sure that in your estimate you have taken into account resources, things like people, test environments, and tools. And there's a number of things to keep in mind here. Now, the first mistake not to make there, assuming 2 people can get the job done in half the time, that is the basis of Fred Brooks' title for his book, The Mythical Man Month. You can't expect that you can just throw more people at the job, because it's brain work. Okay, so you need to think about who's the right person to do the job. What skills are required. If you're going to try to use this as sort of an on-job training task, that's fine, but keep in mind that it's going to take that person longer, and they're going to need to have someone they can go to and ask questions, which means that person that they're asking questions of will get less work done. So that has to all be factored into the equation. Now, your tools and environments, be careful not to overload those. If you overload them, you can end up having problems with false positives, things that look like bugs but are actually just problems in your test environment. You can end up having situations where you're blocked from running an automated test because you don't have enough tool licenses. Now, of course, if you're using open source or custom tools, you're not going to have a tool license issue, but it's something to consider. Also, remember that the environments and the tools will not set themselves up, and they will have problems, and they'll require support. So either you have to do that within your team, or you have to figure out some external resource like a network operations center or something like that that's going to do this for you. And this is a mistake that's easy to make in Agile. See, in sequential projects, we are supposed to be thinking all the way ahead to the end of the project. In Agile, once you get out of release planning, it tends to be this sort of heads down, each iteration is its own thing. You can paint yourself into a corner as a tester really easily that way, and find, for this iteration that we're about to start, we need to have this test tool set up, but this test tool, requires this particular piece of hardware, and that piece of hardware costs $10,000, which needs, executive level management approval or VP level management approval, and that takes 4 weeks to get, and our iteration is 2 weeks long. Whoops, right? So, try to think forward on these things and not get yourself into a trap. Something called rolling wave planning in Agile, which if you're not familiar with that, I'd encourage you to take a look at, so that you don't find yourself in that kind of box. Okay, so metrics. Let's talk about metrics a little bit here, the use of metrics. So Particularly for predicting test execution time, metrics can be very helpful, but they really can be helpful for just about anything. Now, if you're working in an agile world, you'll probably already be familiar with one form of metrics-based estimation, which is velocity that I mentioned before. Excuse me, I had to get a drink of water there. So velocity basically is remember I said that earlier on that a team will have a characteristic with software process capability. Like you get a group of people together, they've got a process that they're following, they're developing software that has certain characteristics from a quality point of view and also from a speed point of view. And that's what you're measuring with velocity. You're measuring the characteristics of that team. In sequential lifecycle models, it's the same type of thing. You can be measuring, average number of requirements elements per person month that get implemented, or function points per person month, those sort of things. So here, what I'm talking about is something that can be particularly useful, which is the application of metrics to try to figure out how long it's going to take to run your tests. Now, the thing that's important here to keep in mind is that this is actually a two-part question. One part of the question is, how long would it take to run every planned test once? Obviously, it can't take less time than that. But also, it's how long is it going to take for us to locate the important bugs, give the developers time to fix those bugs, and give us time to confirm those bugs as fixed. So we have to be able to estimate a few things here. We have to be able to estimate how many tests we're going to need, the total amount of effort that's associated with those planned tests, how many person hours of tester time is going to be available per week or per day, and how much of that time will actually be spent testing as opposed to doing other things like responding to emails and going to daily stand-up meetings and so forth. So through those numbers, if you have those numbers, then you can estimate this is how long it would take to run all the planned tests once. So in Agile, you'd be looking at, okay, for user stories with this kind of risk level, we usually create this number of tests, and each test typically takes this number of hours to run, and so on and so forth. But that's just going to get you through the test once. So then the other thing you need to do is have some way of predicting the number of bugs that you're going to be dealing with. So let's look at these two parts of the problem here. So how long to run the tests, you really have to think about what is your how do you organize your tests? Like what percentage is scripted versus what percentage is exploratory? Also think about your regression testing strategy. Are you running automated tests or are you running manual tests? If they're manual tests, are you repeating them all the time, or do you run them just once? When do you run the regression tests? So if you can make this kind of predictable in the sense of, you draw a picture, go, this is what our test cycles look like, and come up with that picture, then you can start kind of filling in the blanks in terms of how long it's going to take to run the test. So if you say you got something like this, this would be a sequential lifecycle model. You draw something similar, but with a more of a daily heartbeat for Agile. So what we got here is when we're feature complete, we start system test, because that's a sequential lifecycle model, the way it's going to work. Your entry criteria is you start system test when you're feature complete. And so basically what I have is I have these 1 week cycles. In each cycle I get a new test release. And in each cycle, I'm basically going to plan on 1 day of confirmation testing, so 20% of my time confirming fixes for bugs, 3 days of scheduled tests, manual and automated, and 1 day of exploratory testing. Now, this might not be Monday, Tuesday through Thursday, Friday. I could organize it that way, but I could actually have it spread out. But basically, it's 20% confirmation tests, 60% scheduled tests, and 20% exploratory tests, which is a reasonably good rule of thumb in my experience. And now I can go, okay, so this is what I'm going to do in terms of getting through my pre-designed tests. So I got 3 days, and let's say I've got 6 testers, so that's 18 person days. So 18 person days. Now, how many hours is a person going to get in a day of testing? Typically it's not going to be 8 or 9. Maybe they get 5. Okay, so I've got now 5 times 18, so that's 90. I got 90 person hours of testing that are going to get done in a given week. So if I know that I've got, say, 45 tests, and each test takes typically 4 hours to run, those being fairly good-sized tests. So now that's 180 hours of testing, so it's going to take me 2 weeks to get through those. See how to follow the math there? And then I'm ready to start the next pass, so I can go on to that next set of tests, and I'm ready to start the next pass. So now I don't know how many passes I'm going to need yet. I just know, okay, I'm going to have some number of these passes where I'm going through these tests. I don't know how many that's going to be because I need to know the bugs. Before we get to that, let's just point out that in Agile, this is of course different because instead of the testing happening at the end of the iteration, hopefully it's not, it's happening throughout the iteration. And so what you'd be doing here would be looking at, okay, when do we think we're going to get the first thing, and how long is it going to take to test that, and then the next thing, and how long will it take to test that. One of the things that can go wrong with Agile is when people don't break the user stories down into small enough pieces, they end up delivering the code to the testers all at once at the end, and testing becomes a big bottleneck, and then the testers get blamed. It's like, well, the testing is bottleneck, and it's holding us up. Well, no, what's holding the organization up is the fact that test execution doesn't start until the last 3 or 4 days of a 2-week iteration. So you need to be careful that that's not happening, because that's an example of what I was talking about before, of upstream things colliding with your ability to test. So now going back to this issue of bugs, how long to get the bugs out? Well, basically what we need to do first is predict how many bugs there are going to be. Now you need to have some sort of metric of size. Now in Agile you can use your velocity as a metric, as it's probably going to be strongly correlated with the number of bugs that you're finding. Now I say probably, you'd have to test that out. But if the assumption that we can predict the number of bugs based on size is really based on a uniform mistake rate on the part of the programmers, which is of course not a valid assumption if you're going hour by hour, but it is a valid assumption if you're looking like over a period of weeks. So by uniform mistake rate, what I mean is that the developers will tend to make a certain number of mistakes in a given week, which is going to result in a certain number of bugs. And so if I know how much development work there is, some way of sizing, number of person hours, velocity, what have you, then I can say, okay, historically that we've had, this number of bugs per story point, or this number of bugs per developer day, or something like that. And so now if I know how many developer days I've got, I should be able to predict it's going to be this number of bugs. Now in Agile, if everything's under control, this should be, pretty stable from one iteration to the next. You should be finding pretty much the same number of bugs, and so it should be possible to predict, okay, this is going to be this number of bugs, it takes us this long to get through them, therefore we need to allocate that much extra time for just bug fixing into our iterations. Now in sequential projects, this is going to be different because you're not trying to produce a consistent amount of stuff. It's varying. So the number of bugs is going to be a function of the amount of size that was committed to at the beginning. So you need to get those numbers. Ideally, you've got 3 or 4 similar projects from the past that you can look at. You've got a sizing metric. You can then look at this is the number of bugs per developer day, and so this number of estimated developer days for this project. Therefore, we predict this number of bugs. Now, here again, it gets tricky too, because now I've predicted the number of bugs, and I could mathematically say, okay, well, that means this amount of effort, but how long does it take? So what you need is to go back and look at your open-close charts. Now, if you're not familiar with the open-close chart, go out to the RBCS website, go to the basic or advanced libraries, and you can find some examples of spreadsheets out there that create open-close charts for you. They're basically graphing the total number of bugs found versus the total number fixed. Now, the thing that's happening in this chart, though, is that this is not retrospective. It's prospective, by which I mean I've actually looking at things like the closure period, average number of days from discovery to resolution of bugs, looking at things like how many bugs tend to get fixed in each test release, and so forth. I make some predictions about what the shape of this find curve and the shape of this fixed curve are going to be. The spreadsheet that was used to create this chart is another one of those things that you can download, so you can take a look at that. That's going to allow you to predict how long it's going to take to get the bugs out. And pay close attention to that closure period figure. Again, if you're not familiar with what closure period is, you download those metric spreadsheets off of my website. You'll be able to find some examples of that. That can be quite a deal. And I'm working on an assessment report for a client right now, and they thought they told me, oh, the testing it's way too expensive. It takes way too long. Well, I get to looking at their numbers, and it turns out that actually it accounts for about 20% of their project budgets, which is pretty much in line with industry averages in their particular industry and what they're doing. They're adapting off-the-shelf software, customizing off-the-shelf software for in-house use. But interestingly enough, on average, it accounts for about 30% of the project duration. And like, what's going on with that? So I go and look at the closure period, and they had some of these things are just insane turnaround times, like average time to fix a bug of 21 days. Average time, with some of the bug fix closure periods being up in the 100 days. So, if you've got an issue with slow bug repair, or if an issue with a lot of bugs failing the confirmation test and being reopened, that's going to really slow you down. So make sure you're aware of that, because that's, again, upstream stuff coming down and hitting you on the head. Okay, so estimation is tricky. Software estimation is notoriously tricky. We are as a industry notoriously bad at it. One of the things that's happened, with the creation of Agile Lifecycles, and I think a lot of that is in reaction to our failure to apply project management best practices to estimation, failure to discipline ourselves in terms of expectations. I think Agile partly says, well, if we force people to deal with small units of time, they're not going to get overly ambitious, and we can kind of limit that, limit those problems. Some of the advocates of Agile say that it's actually impossible to do long-term planning and estimation properly. I don't believe that. I think it's possible. It's just hard. And the reason I say that is because I've done it before. Because I've been on projects where I didn't do good estimation, and that created problems with my testing, but I did ultimately master some good estimation techniques and have gotten to the point where, I feel like I'm pretty good at it, even if we're talking about a relatively long project. So yeah, there are a lot of good estimation and project management best practices out there. This hopefully has given you some interest in exploring those further. Again, just to recap the main parts of the process, asking experts and the people who will do the work, Delphic, Oracle, Planning Poker, that kind of thing. Using historical metrics and industry averages to look at how long things will take and to check your estimates that the people came up with, whether that's velocity in a agile world or number of bugs per developer hour in a sequential world. And then finally, don't forget the negotiation piece. Negotiation is big. You have to have common expectations and come to an agreement about what the test basis is and how thoroughly it will be covered, and make sure that people understand that constraints on schedule and budget and features translate into constraints on quality as well. All right, I will put the advertisement up and start answering questions as soon as I blow my nose. Question from Patricia here, who says, would you repeat the percentage breakdown for the confirmation testing, scheduled testing, and exploratory testing on slide 12? Sure. Happy to, Patricia. You're referring to this guy here. So basically, 20% of the test time on confirmation testing in a week, 60% scheduled manual and automated testing, 20% exploratory testing. Now, is this appropriate in your particular organization? I don't know. It might be if you're dealing with a lot of bugs, that your confirmation test time is going to be higher than that. Or you're not dealing with many bugs, so your confirmation test time would be less than that, which would be good, assuming that the reason that you're not doing confirmation testing of bugs is because you're not finding a lot of bugs. If the reason that you're not doing a lot of confirmation testing is because the bugs are just languishing in the backlog there, that's not good, because that basically means you've got a lot of technical debt that's accumulating, and this is going to have to be paid for someday. Can you expand the amount of scheduled testing done by using automation? Sure, you can, because basically the amount of effort would stay the same, but the amount of testing that would be done would be higher. So I'm talking about 60% of the effort is being spent on scheduled tests, but if you have a very high percentage of tests that are automated, that could be a whole lot of automated testing happening. And what might even happen there, what can happen in really well-functioning, mature Agile implementations where they do have a high percentage of automated tests, is that they see the effort associated with scheduled tests go down and the extra effort associated with exploratory testing go up, because the tests that can be pre-written end up getting automated. And so they're just being run in an automated fashion. Now, this is not something, of our clients that are doing Agile, most of them are not there. So don't say, oh, we're doing Agile, so therefore that means that we can spend a lot more time on exploratory testing and less time on scripted tests. No, not you have to get there. You can't just go, oh, well, we should be there. No, well, maybe you should be, but you're probably not. So beware of that. Oops. Well, that's frustrating. I don't know why I did that. Sorry, let me fix that. Decided to go out of presentation mode. Now it's back in presentation mode, and hopefully you're all seeing the right thing here. Let me just verify that you're seeing. Yep, you are. Okay. Let's see. Now I got a question from Steve, who says, due to siloed expertise within our Agile team, our planning poker sessions often have many abstentions. Do we force participation even when the participant doesn't understand the impact? If we don't, we end up having 2 people representing the team of 10. Interesting. Yeah, I mean, I think that there's very little point in having somebody give an estimate that they don't know. You know, I mean, except as like a carnival game, right? Like the old thing about how many peanuts are in this jar. Have you ever done that at like a state fair or something like that, or you know, rodeo or something? Is usually somebody's going to have a jar of peanuts or something, a jar of marbles, and you know how many marbles are in there. I mean, you know, you don't know. I mean, you could, I guess, sit back with a calculator and try to calculate, well, what's the volume of the typical peanut, and what's the volume of this, and but you know, most of the time it's just going to be like people going, I'm going to guess this. That doesn't. That's a funny game, but it doesn't add a whole lot of insight, right? So basically, if you force people to participate in the planning poker sessions, you're just injecting noise into your estimate, which is by no means good. Now, I think that the abstainers can participate in the discussion about the estimate, and that could add value, and certainly they could learn from that. But I think ultimately, Steve, you put your finger on the problem, which is the siloed expertise. You know, now I'm all for specialization. You know, so one of the great myths that floats around in the Agile universe that was put there by some of the founding fathers of Scrum is that anybody can do anything. One day you can be a designer, and the next day you can be a programmer, and the next day you can be a tester, which is you know, not basically that's saying you don't require any particular expertise or knowledge to do those things, which is, you know, of course, untrue. But you know, you can go too far on that specialization and get to this siloing problem. So what I would suggest is you try to do some cross training and get some skills growth across your team so that you get away from the siloing. But again, forcing participation, I would say no, that doesn't make any sense, because as I say, that's just injecting noise into your estimate. Donald says, can you explain more about overloading tools? Sure. Basically, if you've got a commercial tool and you have a certain number of licenses, overloading tools would be trying to have too many people on based on the number of licenses. That would be, the tool would be overloaded, and in that case, it would not allow you to use the tool, right? You know, you get some sort of error message, and it would say, sorry, can't do it. So that would be an example. Now, another thing that can happen is not exactly overloading, but it's kind of related, which is where you try to run automated tests in a single environment where there's a shared data store. And they end up the tests end up kind of scribbling on each other's data, and you get a bunch of false positives. You could say, well, that's overloading the environment, not overloading the tools. Well, I suppose it's overloading something. So you have to be careful when you're talking about running automated tests that you're not going to have situations where you run out of licenses or run out of some sort of resource. You know, the tool basically starts screwing up because of the way you're using it. I saw an interesting example of that once, where a set of performance tests appeared to pass, but when we looked more closely, we realized that we were running the load generator on a system that was underpowered, had insufficient CPU and memory resource to create the number of virtual users that we wanted to create. So the response time appeared to be good at the target number of users, but I mean, what was actually happening is that we weren't getting to the target number of users. So that's another kind of related thing. So you have to be careful when you're doing any sort of automated testing. Ian says, from your experience, any ideal time for agile sprints in weeks? I don't, I've seen people do 1 week. I've seen people do 4 weeks. To me, you know, 1 week seems awfully short. If you can make it work, good for you. 2 weeks, that seems like a bottom end of reasonable. But we've got clients now that are totally kind of breaking out of that whole iteration mode and getting into things like Kanban, and just saying, we're not going to worry about sprints per se. Everything is just kind of going to move on its own schedule, and it won't be time boxed. So I don't, if you got a particular iteration speed and it works for you, both from a testing and development point of view, I'd say that's the right thing to do. Mark says, is confirmation testing also meant to include regression testing, and are there assumptions that can be made about regression effort and estimation? So no, confirmation testing is confirming that a bug fix does actually fix the bug. So at the very least, it should include rerunning the steps to reproduce the bug that were documented in the bug report. It might also include rerunning the tests that failed because of the bug. Check to see if those problems are now fixed and if those tests now pass. But neither of those activities, to me, would qualify as regression testing. Regression testing is running tests of things that weren't changed to make sure that they weren't broken. Now, of course, the holy grail here, the ideal objective would be to have all those tests automated, but that's seldom the case. Nose blow there. That's seldom the case that you're going to get to 100% automation. So what you're going to need to do from a regression effort and estimation perspective is look at how much of your regression testing is automated and how long does that take to run. Hopefully not very long, and hopefully you spend very little time of that dealing with false positives. Make sure you look at that. If you're spending a lot of time going through and analyzing your automated test results and updating the tests because you're getting a lot of false positives, you're not doing it right. Your tests are not. Your tests have a maintainability problem. So part of the equation here with the regression effort and estimation has to do with your automated tests. The other has to do with the manual tests. Now, with the manual tests, what you have to do is figure out how you are going to select the tests that you're going to run, because you're probably not going to rerun all of them. You might be able to do that at first when your system is relatively small and simple, if you're dealing with some kind of iterative or incremental development, but eventually the size and scope of the system is going to overwhelm you. So you need to have some sort of method of picking what you're going to test. Now, you can use your risk analysis, to try to figure out the highest risk areas, and by all means try to automate those, because the high risk areas are the ones that you're going to want to rerun a lot, right? If you, for whatever reason, if you can't automate all of those, then I guess you're going to have to run those manually. And you also need to be able to do some sort of impact analysis to look at the things that have been affected or could have been affected by the change that was made. Those you'll have to run, and a properly managed repository of manual tests that you can use to go back and say, okay, for these requirements have been changed or affected by the change, and we use our traceability to go look at the tests that relate to those requirements. Those are the tests that we need to run based on this change, right? That part of the process should be pretty straightforward, and you want to design your test repository, your traceability, and your impact analysis such that the process of selecting the manual tests to run is pretty straightforward, at least selecting the manual tests that you should run. And then at that point, you should have some historical data on how long these manual tests take to run. You know how many there are, So that's going to tell you, okay, this is the number of person hours of regression testing we need to run. Now, then you're back to negotiation, because people are going to have to decide, well, if the total amount of testing to test the new features and to regression test the things that were not changed exceeds the amount of testing that we're willing to invest, where are we going to cut? Going to cut regression testing? Are we going to cut scheduled testing? Are we going to cut both equally, one more than another? So again, negotiation rears its ugly head. Zachariah asks, I hope I'm getting that name right. Which metrics do you suggest that we record during testing that can be used for test estimation for subsequent projects and iterations? Huge sneeze there. Well, you want to look at bugs, the number of bugs found. You want to look at estimated hours and actual hours for your various tasks, especially your test execution. You want to make sure that you want to know that. Anytime you run a test, you want to record how long it took to run the test, assuming it was a manual test. So yeah, those kinds of things, the number of developer hours that were spent, the number of hours that people actually spend on task. So like during test execution, how much time do they actually spend running tests as opposed to doing things like sending emails and doing confirmation tests and so forth. And you have to look at those kind of things. The closure period, how long it takes for bugs to get fixed, and how stable that is over time. Is it predictable? Is it unpredictable? That has a lot of implications. The point at which your bug backlog starts to impose inefficiencies. So this could be a complex analysis to do, but if you can, looking at correlation between the bug backlog and your bug duplication rate and your false positive rate, there probably will be one. If you can't do that, you should just look for situations where your bug backlog exceeded 50 on a sequential lifecycle project. On an agile project, the number should be much lower, because bug backlog is going to lead to a lot of duplication and a lot of false positives. So you want to look at backlog. So those are some things that I would start by keeping track of. Longtime listener Tuyen says 4-week iterations seem to work well at my organization. So good. Yeah. So if it works, I'd say stick with it. Ivana says, do you know if somewhere is available any kind of estimation tool that is reusable, maybe an Excel sheet with parameters and formulas? Well, there's a bunch of stuff out on the RBCS website. If you go out to the basic library and to the advanced library and you look under the heading test estimation, there are a bunch of spreadsheets that you are certainly welcome to download and use. They're fairly crude, but they've worked for me on a number of projects. There are tools for estimation, but they tend to be expensive, and that might not be something that you want to get into. There are also books out there that have industry numbers in them, specifically Capers Jones's books like Estimating Software Costs and Economics of Software Quality. So, I'd encourage you to take a look at those too, because those can give you some numbers that will help you, benchmark where you are against industry averages. Fani asks, basically, I think just what I just said. Do you have sample spreadsheets that can be used effectively for estimation on your website, or is that something that you can send to me? Yeah, you can download this stuff off the website. Please don't send requests to me or to info asking us to find for you and email to you stuff that I have referenced off of our website. This is a free webinar service. We're happy to offer a free webinar service, but we're not going to Google that for you. Okay, so Yeah, the website's a little clunky. I apologize for that, but it's, you should be able to find those the spreadsheets by just going to the basic library or the advanced library. That's the resources tab, basic, advanced libraries, and then find the test estimation section in each of those pages, and voila, tons of free spreadsheets. Now, I want to be clear, there's nothing magical about those spreadsheets, right? That's stuff that I've put together over years. You're going to need to fine tune it. You're going to need to adjust it. Okay. But can it be a good starting point for you? Sure. Absolutely. Can it give you some food for thought? Yep. Absolutely. Does it cost anything? Nope. It's free. Let's see, on the whole, how is the audio quality? I think people were kind of all over the place on this. And Jean said that she had problems with it. Yuri said it was fine. Saraswati said that it kind of came and went, sometimes okay, sometimes not okay. Craig said sometimes it's okay, sometimes it's not okay, sometimes it has ringing. Shauna says audio is great. Kristen says it's fine. Zechariah said I can hear clearly. Rex Parsons says good for me. So yeah, I would say if you were having problems with your audio, it was probably a connection speed issue at your end. Look into that. When you go out and you watch videos from YouTube and other kinds of stuff, do you notice that you've got a lot of buffering happening? If you do, then that's going to mean that you've got a connection speed issue. If sometimes your connection's fast and sometimes it's slow, which will happen with Wi-Fi or with busy network connections, that will also result in this. So there's very little I can do on that to improve the audio quality. Just try to improve your connection speed. You can always come back and listen to the recorded version, which if I've got a good connection, that will be clear. Deepak, Dirk, Anna, and Ian all say that the audio quality is great, as does Rolf. So Miriam says, thank you for the great and informative training. Mohammed says, thanks for the great session. Well, thank you to you both for attending. I'm glad it was useful to you. Appreciate all of you who did come out for this best of presentation, even though this is one that we've done before. It's actually quite different. So if you have colleagues who said, I'm not going to attend that one on test estimation because I've heard it before, you might say, hey, you might want to listen to the recorded version because it's pretty different. I had a lot of information on Agile in here. So and Patricia says, agree. Thank you for the informative session. Preeti too says, very informative. Thank you. Audio quality was great. Ivana, thanks for the webinar. Great as always. Good. Well, thank you for the kind words. I'm glad that we had much fewer technical issues this time than we did last month. So let me just close the session down. A little bit more about the resources. You know about the free webinars, so you visit our website to sign up. Of course, we can do these for you for a fee if you want, for your company only. So you can send email info@rbcs-us.com. Our regular free newsletter also, sign up at rbcs-us.com. We give discounts. And by the way, we are running a huge discount right now through the end of day tomorrow. 20% off everything, absolutely everything in there. So if you didn't get that email, you send an email to info@rbcs-us.com and ask for the information about the 20% discount. So that's the kind of thing that happens from time to time. We get these flash sales. You also get a regular newsletter that will include a featured article on our testing and quality and news about what we're up to. We're on Twitter at RBCS and at Like a Test Dog, as you see there. Like a Test Dog is the personal one. So if all you want to hear about is testing, do the RBCS one. If you want to hear me bloviate about the 2016 election, you can get more of that from Like a Test Dog. We're on Facebook, RBCS-INC. Don't forget to check your email over the next couple days because you could be the lucky winner of the free e-learning course. There's one winner each month. Actually, this month there were two because we had an encore presentation, the technical problems last month. So there'll be another winner drawn based on today's attendees. And don't forget the digital library. So again, resources tab, navigate to the digital library. These webinars are recorded and posted out there within a few days of being done. We also post podcasts as RSS feeds of them. There are videos out there. We're on iTunes Store if you want to get a podcast there. We've got the RBCS channel on YouTube where these webinars are also posted. So we're all over the internet like a bad rash, as the saying goes. We offer these free resources as a service to the software testing community because at RBCS we are a not just for profit company. This concludes the webinar. Thanks to everyone for joining us today. Have a great holiday and see you next year.